Good morning, students. So, in subject Electronics Device and Circuit, chapter number 3, Electronics Amplifier. So, last time we have started the chapter number 3, that is Electronics Amplifiers. So, from that we have seen what is that the feedback amplifier. Okay, and basically the negative feedback amplifier is used. So, what is feedback amplifier and why it is required? Because when we are giving any input for the amplifier, so it at the output will come million times of that the input. So suppose is any disturbances will occur at the input side, that also gets amplified in a large amount at the output. So to avoid this or to reduce that the noise level minimum, we have to use the negative feedback. So negative feedbacks we have seen, that is we have seen the electronics amplifier circuits, that is voltage amplifier, current amplifier, transconductance amplifier and transresistance amplifier. Okay, so today we are going to see the concept of feedback. Okay, so an amplifier circuit simplify increases the signal strength. Okay, in the last session we have seen the classification of amplifier and amplification. So today we are going to see the concept of feedback. So an amplifier circuit simply increases the signal strength. But while amplifying, it just increases the strength of its input signal, whether it contains information or some noise along with information. Okay, so while amplifying, it just increase the strength of its input signal, whether it contains information or some noise along with information. So this noise or some disturbance is introduced in the amplifiers because of their strong tendency to introduce hum due to sudden temperature changes or stray electric and magnetic fields. Okay, so this noise or some disturbance is introduced in the amplifiers because of their strong tendency to introduce hum due to sudden temperature changes or stray electric and magnetic fields. So therefore, every high gain amplifier tends to give noise along with the signal. Okay, so therefore, very high gain amplifier tends to give noise along with signal in its output. So which is very undesirable. Okay, so which is very undesirable. So the noise level in the amplifier circuit can be considerably reduced by using negative feedback done by injecting a fraction of output in phase opposition to the input signal. Okay, so the noise level in the amplifier circuits can be considerably reduced by using negative feedback done by injection a fraction of output in phase opposition to the input signal. So you will get the idea, concept of feedback. So in an amplifier circuit, it just increases the signal strength. But if suppose there is a while amplifying it just increases the strength of its input signal. No, it will amplify the input signal as well as that the whatever the noise is added into that the input signal. So we have to reduce that. And why the noise is occurring at the amplification? Because disturbance is introduced in amplifiers introduce hum due to sudden temperature changes or straight electric and magnetic field. Therefore, very high gain amplifier tends to give noise along with signal in its output, which is very desirable. So noise level in the amplifier circuit can be considerably reduced by using negative feedback done by injecting a fraction of output in phase opposition to the input signal. Okay, so there is a necessity of the negative feedback. So let us see the principle of feedback amplifier. So which type of the feedback is required for that the feedback amplifier? So a feedback amplifier generally consists of two parts. So which are the two parts? There are the amplifier and feedback circuit. Okay, so feedback amplifier consists of two parts, the amplifier circuit and the feedback circuit. So the feedback circuit usually consists of resistors. Okay, so the concept of feedback amplifier can be understood from the following figure. So for example, we are going to take one feedback amplifier where it will consist of two parts. One is the amplifier circuit with gain A and another is the feedback circuit. So feedback circuit is nothing but the consist of resistance. Okay, so from this side we are applying the input and we are taking the output. So which is nothing but the amplifier as well as the noise reducer, because whatever that the noise that will fade with that the input side. Okay. So from the above figure, the gain of the amplifier is represented as A. Okay, so in figure we have seen the gain of the amplifier is represented by A. Then feedback circuit factor is the beta. Then input voltage is Vi. Then feedback voltage we can represent, that is beta into V0, and this is nothing but our output voltage. So a gain of the amplifier is the ratio of output voltage V0 to the input voltage Vi. So that already we know that the gain is nothing but the output divided by input. So the feedback network extracts a voltage. Which voltage? Vf, that is beta into V0 from the output V0 of the amplifier. Okay, so this circuitry extract the part of that the voltage, and that is nothing but the Vf is equal to beta into V0. Okay. So this voltage is added for positive feedback and subtract for the negative feedback. Okay, from the signal voltage Vs. Okay, so this voltage is added for the positive feedback and subtracted for the negative feedback. Okay, so keep in mind, so this extracted voltage is either added or either subtracted, but if it is added then it is known as the positive feedback, and if it is subtracted then it is known as the negative feedback. So signal voltage Vs is represented by like this. So input voltage is equal to Vs plus Vf, so that the positive feedback is Vs plus beta V0, sorry, and for the negative feedback Vi is equal to Vs minus Vf. So this quantity, that is beta is equal to, what is the value of the beta? Beta is equal to Vf by V0, is called as the feedback ratio, or we can say feedback factor, feedback ratio or feedback fraction. So let us consider the case of negative feedback. The output V0 must be equal to the input voltage. Okay, the output V0 must be equal to the input voltage multiplied by the gain A of the amplifier, multiplied by the gain of the amplifier. So hence this is the input voltage, then gain is equal to output. So output is given like this, or we can say AVS, A beta V0 is equal to 0, or we can say, so take this term as it is here, AVVS, equal to V naught. Take the same terms for this side and take out the common that the character V naught. So you will get AVS is equal to V naught into 1 plus A beta. So therefore V naught divided by Vs, that is A divided by 1 plus A beta. So let's AF be the overall gain with the feedback of the amplifier. So this is defined as the ratio of output voltage V naught to the amplified signal voltage Vs, that is this overall feedback AF is equal to A divided by 1 plus A beta. So this figure indicating that overall gain of the amplifier. So the equation of the gain of the feedback amplifier with positive feedback. Okay, with the positive feedback, so you will get this equation. Okay, for negative feedback we are considering this, but for the negative feedback we are getting like this equation, and if you want the for the positive feedback then you will get this equation. Okay, so this is for the negative feedback and this is for the positive feedback. So these are the standard equation to calculate the gain of feedback amplifier. Okay, once again we are going to look that. See here, this we are going to see the feedback amplifier circuitry. So feedback amplifier consists of two parts: amplifier with gain, feedback circuit, fraction beta. This is the output side, and whatever that the fraction is extracted, that is Vf is equal to beta V naught, that is fed to the input side. So generally that the A represents that the amplifier gain, V out is the output, input is the Vi. So feedback network, so it is represented that Vf is equal to beta V naught. So from output V naught of the amplifier means part of that is extracted from that the circuit. Okay, so from this side, this is the part of the output, that is Vf is equal to beta V naught. So this voltage is added for positive feedback and subtracted for the negative feedback. So due to that we have written input is equal to Vs plus Vf for the positive feedback, and this is for the negative feedback. So we know that the quantity beta is nothing but the Vf by V naught feedback fraction. So let us consider the for the negative feedback, the output V out must be equal to the input voltage this and multiplier gain A. Okay, so this V out is given by this equation. So rearranging this equation and taking the common factors outside, then we get that the V naught divided by Vs is equal to A divided by A 1 plus A beta. So we can say this is the output voltage divided by input voltage. So we can say this is the overall gain of that the circuitry. So for that the negative feedback, the overall gain of the circuitry is A divided by 1 plus A beta, and for the positive feedback it is AF is equal to A divided by 1 minus A beta. So these are the standard equations of the gain. Then, so let us see the types of feedback. So the process of injecting a fraction of output energy of some device back to the input is known as the feedback. So it has been found that feedback is very useful in reducing noise and making the amplifier operation stable. Okay, so the process of injecting a fraction of output energy of some device back to the input is known as the feedback. It has been found that feedback is very useful in reducing noise and making the amplifier operation stable. So depending upon whether the feedback signal aids or opposes the input signal, there are two types of the feedback used. Okay. So one is the positive feedback and another is the negative feedback. So let us first upon see positive feedback. So the feedback in which the feedback energy, that is either voltage or current, is in phase with the input signal and thus aids, it is called as positive feedback. Okay, the feedback in which feedback energy, either voltage or current, is in phase with the input, thus aids, it called as a positive feedback. So both the input signal and feedback signal introduces a phase shift of 180 degree, thus making 360. So resultant phase shift around the loop to be finally in phase with the input signal. Okay, input signal and feedback signal introduce the phase shift of 180 degree. So thus making that the 360. So it is finally with the input signal. Though the positive feedback increases the gain of the amplifier, it has the disadvantages such as increasing distortion and instability. Okay, so positive feedback increases, it will affect and it will increase the distortion as well as the instability. So it is because of these disadvantages the positive feedback is not recommended for the amplifiers. So if the positive feedback is sufficient large, it leads to oscillations. Okay, if the positive feedback is sufficiently large, it leads to oscillation by which oscillator circuits are formed. Okay, so see here one most important part, we have seen what is meant by feedback. So depending upon the which type of the feedback is applied to the circuit, the feedback is also having the two types. So one is the positive feedback. So what is meant by positive feedback? So that input and output in phase. Okay, so it is called as the positive feedback. So here that phase shift is 0. But what are the drawbacks of the positive feedback? Because if the increase the gain of this amplifier, so increasing the distortion as well as the instability. So positive feedback, if they having the sufficient gain, then we can use this positive feedback for the oscillator circuits. So from that positive feedback, oscillator circuits are formed. Then negative feedback. The negative feedback in which the feedback energy, that is either voltage or current, is out of phase with the input, and thus opposes, it called a negative feedback. Okay, the feedback in which the feedback energy, that is either voltage or current, is out of phase with the input and thus oppose, it is called a negative feedback. So in negative feedback, the amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network is so designed that it produces no phase shift or zero phase shift. Okay, in negative feedback, the amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network which doesn't have any phase shift. So thus resultant feedback voltage, that is Vf, is 180 degree out of phase with the input signal Vin. Okay, so due to that the resultant feedback voltage Vf is 180 degree out of phase with the input signal Vin. So though the gain of negative feedback amplifier is produced, there are many advantages of negative feedback. So such as stability of gain is improved, reduction in distortion, reduction in noise, increase in input impedance, decrease in output impedance, as well as increase in the range of uniform application. So what are the advantages of the negative feedback? Stability of gain is improved, reduction in distortion, reduction in noise, increase in the input impedance, decreasing in the output impedance, and increase in the range of uniform application. Okay, so we have seen positive feedback as well as the negative feedback, but the positive feedback having its own drawback, so they cannot be used in an amplifier. But in a negative feedback, it is having lots of advantages, so that negative feedback is mostly used in a amplifier, feedback amplifier circuits. Okay, so stability, then it will improve the stability, reduction in distortion, reduction in noise, increasing input impedance, decrease in output impedance, and increasing the range of the uniform application. So we have seen the principle of the feedback amplifier, then we have seen the types of the feedback, that is negative and the positive feedback. Thank you.